Hello, myself Professor Harish Bangade. I welcome you in a video lecture series. So we'll discuss about the subject of first year engineering, basic electrical engineering. So today we are discussing about the alternating currents. So in last lecture we have already studied how the electricity is generated and what are the different forms of the alternating currents, what are the different equations that we have studied. Now in part 2, let us discuss about the different terminology related to alternating current. So here the terminology is related to the sinusoidal waveform or AC waveform. So observe this figure, it is the sinusoidal waveform. Now the sine wave, we always knows it constitutes a positive half cycle and a negative half cycle. Okay, in generation we already studied how this sinusoidal wave is generated. So it constitutes a positive half part, here positive half cycle, and here is negative half cycle, and both will form a complete cycle. Okay, now the different terminology related to this alternating current is the first is an instantaneous value. Now what is meant by instantaneous value? Now we always know that the values of this alternating current are varies with respect to time. At every instant of time, this alternating current has a different and different values, and the set of these alternating quantities of different values is repeats it alternatively. Okay, so at every instant of time, it has a certain fixed value, and that is nothing but your instantaneous value. So the instantaneous value can be defined as the value of an alternating quantity at a particular instant is known as its instantaneous value. For example, if at time t we have considered at this time, so let us say here is the certain value t at time t is t1, certain e1 value will be there. Okay, at time here t2, your maximum value will be there. At time t is equal to 0, this value is 0, right? So in this way, at every instant of time, it has a different and different instantaneous values. Next, well, terminology related to this AC waveform is the waveform. This, how can we define the waveform? So this is a waveform. Okay, so how can we define it? So waveform is nothing but it is a graphical representation of the sinusoidal alternating values, and this is nothing but a graph of the instantaneous values of an alternating quantity plotted against time is called as a waveform. So this is simply nothing but it is a graph of instantaneous values, and this graph of instantaneous value is plotted against the time with respect to time, and that is nothing but its waveform. Second definition related to this is a cycle. So this is a complete cycle, positive half cycle and negative half cycle. So each repetition of a set of positive and negative instantaneous values of the alternating quantity is called a cycle. So each repetition of positive and negative instantaneous values of the alternating quantity is called a cycle. So such a repetition occurs at regular interval. So such a repetition, this positive and negative, this set of these values is again repeated. Here also the same set is there. Okay, the time changes. So such a repetition of this set of the positive and negative half cycle is nothing but your cycle. Okay, so such repetitions are there that exhibits variation and that reoccur after a regular time intervals, and that is called as the periodic waveform. So cycle can also be defined as that interval of time. That interval of time. Cycle can be defined as that interval of time during which a complete set of non-repeating events or waveform variations occur containing positive as well as negative loops. So that is nothing but your cycle. Okay, so the one cycle, one such a cycle of an alternating quantity here is shown. Okay, so this is the first cycle, this is the second cycle. Okay, so repetition of this positive and negative set that constitutes the cycle, and the one cycle corresponds to 2 pi radians. The one cycle corresponds to 2 pi radians or 360 degree. Okay. So next definition is a time period. So here is the time period T is shown. So what can we define? How can we define a time period? So it is nothing but the time taken by a one complete cycle. The time taken by an alternating quantity to complete its one cycle is known as its time period, and it is denoted by T, and it is always measured in second. So after every T seconds, the cycle of the alternating quantity repeats. So this is shown in figure. So this is first cycle. In T second is completed. Second cycle, another next T second is completed. So likewise, number of cycles are there. Next definition will define frequency. So what is the frequency? Frequency is nothing but the number of cycles completed by an alternating quantity per second is known as its frequency, and it is denoted by F, and is measured in hertz. So F is equal to 1 upon T. It is simply reciprocal of the time period. The next definition we can see the amplitude. So what is the amplitude? The maximum value attained. So this is the maximum value attained during the positive half cycle. Okay. So the maximum value attained by an alternating quantity during positive, also in a negative half cycle. Negative में भी इसने maximum value attain किए negative direction में, और positive direction में भी ये maximum value attain किए, plus a max or minus a max. It is nothing but your amplitude. So the amplitude can be defined as the maximum value attained during positive half cycle or negative half cycle of an alternating quantity is known as the amplitude, and it is denoted by EM. It is denoted by EM or IM or VM. Okay, the EM is called the peak value of the voltage, but IM is called as the peak value of the current. So the peak value you can see here. So it is the amplitude. It is a peak value. Okay, and it is a peak to peak value, positive max to negative max, that is peak to peak value. And this peak to peak value we can define as the value of an alternating quantity from its positive peak, value of the alternating quantity from its positive peak to its negative peak is called its peak to peak value, and it is denoted by either IPP if it is current or VPP if it is voltage, and the amplitude is always 1/2 up to that of peak to peak value. So amplitude is peak to peak value upon 2. Okay, next definition we can define as a angular frequency. The angular frequency is denoted by letter omega, and it is the frequency expressed in electrical radians per second. So as one cycle of an corresponds to 2 pi radians. Okay, यहाँ पे 2 pi radians, that is 360 degree में ये complete होता है. It corresponds to 2 pi radians. The angular frequency can be expressed as 2 pi into cycles per second, that is denoted by omega, and its unit is radian per second, and the radians between frequency f and angular frequency omega is equal to 2 pi f. So omega is equal to 2 pi f, that is the radian per second, and it is the angular frequency. So these are the different terms related to an alternating quantity. Now let us see the next definition for RMS value or effective value of an alternating quantity. Now what is the RMS value or effective value? An alternating current varies. We know the alternating current, it varies with respect to time. Okay, at a particular instant, the value of the alternating current is different. So it varies from instant to instant, while the direct current is constant. Direct current, if you compare with this AC, then it is constant. It is a straight horizontal line. Okay, it is not varies. In that every instant of time, the current value or voltage value is constant, steady. So for this comparison of the two, a common effect to both the type of current can be considered, such as an effect is a heat produced in a resistance when we allow to flow either AC currents or a direct current. So that heating effect can be compared. Heating effect can be compared. The alternating and direct current from this RMS value of an alternating current can be defined. So here one resistance is a 2 ohm resistance. Here is a 2 ohm resistance, and from this 2 ohm resistance we have allowed to flow. We have allowed to flow the DC current as well as AC alternating current. So here we have allowed this 10 volt RMS current and 10 volt DC current. Battery is connected, here AC signal is given. Okay, so that much amount of current we are allowed to flow through this 2 ohm resistor for a particular time period. In the same time period, we are allowed to flow DC as well as AC current. So how can we define RMS value? So the effective value or the RMS value of an alternating current is given by, it is given by that steady current, that is DC current, which when flowing through a given circuit, given resistance for a given time periods, produces the same amount of heat. It produces the same amount of heat as produced by the alternating current, which when flowing through the same circuit, same resistance for the same time. So that is nothing but your effective value or RMS value. I repeat again, the effective value of the RMS value of an alternating current is given by that steady current which when flows through a given resistance for a given time produces the same amount of heat as produced by the alternating current through the same resistance for the same time period. So that is your RMS or effective value. So in this way we can define the RMS or effective value. Now how can we find out this RMS or effective value? There are two methods for finding the RMS value. We can determine or calculate the RMS value analytically and graphically. So your graphical method is mentioned. So how can we find out the graphically? So consider here the sinusoidal varying current. So here the waveform shows a sinusoidally varying current. Okay. Now at every instant of time, like time t1, t2, t3, the values of current will be instantaneous value of the current will be I1, I2, I3, IN. So such a RMS value is to be obtained by comparing heat produced. Okay, we will compare by heat produced by flowing this RMS value. So heat produced is proportional to square of current, that is I square R. So heat produced in the resistance is always proportional to the square of the current, I square R. So the heat produced in both positive and negative half cycles, whatever the heat produced during positive half cycle, same amount of heat will be produced in negative half cycle. Okay, and hence consider only positive half cycle. So we will consider only positive half cycle because same amount of heat will generate. So hence consider only positive half cycle, which is divided into this n interval of time. This positive half cycle is divided into n interval of time as shown in the figure. Now the width of each interval corresponds to t upon n. If it is total t time period for half cycle, then each interval corresponds to t upon n second. And average height of each interval is assumed to be as the average instantaneous value of current, that is I1, I2, I3, I4, dash IN. So now let us this current be passing through resistance R. अभी यही करंट हम कहाँ से पास करने वाले हैं? एक रेजिस्टेंस से पास करेंगे. So hence heat produced can be obtained as, so heat produced is always equal to I square RT and it is in joules. So total heat produced is equal to I square RT joules. Now we will consider only first interval. So during first interval I1 current will flow. So the heat produced due to first interval is equal to I1 square R into time period is T upon N. Similarly, heat produced during second interval of time T2, it is T by N time and the current is I2. So the heat produced is equal to I2 square RT upon N. Similarly, for nth interval, it is IN square RT upon N. So in this way, the heat produced during each interval of time is like this, and therefore the net or the total heat produced in T seconds is R into T into sum of all these, that is I1 square plus I2 square plus IN square upon N. So in this way, the total heat will be there. Now the same amount of heat is produced when it is produced when a RMS AC current is flows through the circuit or the resistance. So for And to be the RMS value of an alternating current, these two hits must be equal. So it is I square RT that equal to, this is R into T, I1 square plus I2 square, that IN square upon N. So R of T will get cancelled and you will get I square is equal to sum of the square of all the instantaneous value upon N. So I is equal to the square root of this, and it is square root of I1 square plus I2 square plus that IN square upon L. And what is it? It is nothing but the square root of the average square of the sum of the average values. So it is nothing but your RMS value. So IRMS graphically can be find out like this, and it is always equal to 0.707 IM. And if it is voltage instead of current, I consider voltage, then VRMS is equal to square root of V1 square upon V2 square plus dash Vn square upon N. So VRMS is equal to 0.707 Vm. So in this way, the RMS value can be computed graphically and analytically. Now we'll see how to find out the RMS value. Okay, so this RMS value graphically we have find out. Now analytically how to find out, that we'll see in next lecture. Till then, thank you.